Hi all, here's our next video lesson. I promise it will be much shorter than that last one, okay? It should look like the screen I have up right now. Our focus is on medians and altitudes. So once you get this sheet out, we will get rockin'. Okay. So kind of like our last lesson, we're gonna learn what a median is, we're gonna learn what an altitude is, and then we're gonna use those properties of those segments and find missing lengths in our triangles, okay? So without further ado, let's get started. So we first have a median, okay? And all a median is, it's a segment joining a vertex, so like the corner of our triangle, to the midpoint of the opposite side. Okay, so again, the median joins the corner of our triangle to the midpoint of the opposite side. How do we know for sure that's the midpoint? Well, don't be silly. It has those tick marks, and that's how we know, right? Because it's in the middle, so then both of those sides are congruent. Okay? Just like we had 3 perpendicular bisectors, we had 3 angle bisectors, we have 3 medians to a triangle. And where all 3 of them intersect, we call the centroid. Yes, the centroid. So now we're just like our other lesson, we're going to look at this picture and list a bunch of stuff about it, okay? So up first it says list the medians. The medians. So remember the median goes from the vertex to the midpoint of the opposite side. So our first one here, let's start at the top. B to F, that's a median. So BF, we go around, C, D is a median, and then A to E. Our centroid in this picture would just be point P. And now here's kind of the fun part. So with our median, it splits into 2 parts at our centroid, okay? So it splits into a third and 2/3. So if we look, let's say at, I don't know, which one should we use? Let's look at AE. So PE here makes up a third of the whole thing AE, okay? So PE equals 1/3 of AE. So now you could think PE also makes up a half of AP. I know I'm throwing a lot of letters and fractions at you, which we don't really like in math for whatever reason, but think about it. I'm gonna go like this. If I split like this into thirds, right? And here is PE, it makes up a third of the whole thing. What fraction does it make up of what's left? It makes up a half of it, right? Because another block like this would fill up one more block. So it's a half of our remaining AP. This is why I don't teach 3rd grade or whenever you learn fractions, but this is why it works. I don't know if that helped you or hurt you, but just know that PE is also half the distance from A to P. Okay? Or you can think of it like this, that AP is 2/3 of our whole thing of AE. So from A to P is 2/3 of our whole median. Or that AP is 2 of our PEs. Again, like I always say, this part of the math is confusing. When we try actual numbers, actual concrete problems, it clicks. Get down the theory, the formulas, so you can reference it later. But when we try another, like a problem in just a second here, it will click, I promise. Big takeaway, your median, I lied, your centroid cuts your median into 2/3 and a third. Okay, let's try some of these. Oops. So it says Z is the centroid of triangle TUV. TV, like TZ, let's see here, is 60. And XZ is 28. And WZ is 25. Our job is to find the missing measure. Okay, again, let's forget about this column over here. Let's fill in what we know. Let's start with this 25, okay? So think this is my small part. It's the third of WU. So I can double this to get this guy right here. So 25 times 2 would be 50. Similarly, XZ is the third of XV. So to find ZV, we just double it. So 28 times 2, 56. Now our last one here, this time they give us the 2/3 part, right? So TZ is 60. How do I find my third? We cut her in half. So half of 60 is 30. Now let's see how we did. So ZV, 56. ZY, we said is 30. ZU is 50. TY, add them together, 60 plus 30 gives us 90. And XV, again, we're going to add them together, 28 plus 56 gives us 84. Okay, I think this would be a really great time for you to pause the video and try this one before I do it with you. So take a second, pause it, see how far you can get. Same exact type of problem, different numbers. You have a third and 2/3. Are you doubling it? Are you halving it? Or are you adding them together? Ready, set, go. Okay, I'm going to start. I'm trusting that you at least attempted this on your own. I'm going to label what they give me. AG is 8. GF, we love Grand Forks, is 7. BG is 5. Okay, here we are, folks. Let's start with our BG5. So this is my third. To get GE, I'm doubling it, so it's 10. Same thing here, 7 is my third. I double it to get CG, which is 14. Now AG is my 2/3, so to get my third, I half it, which is 4. So let's see how this went. 4, AD, we're going to add them together. We get 12. CG, we said, is 14. GE is 10. And BE, we add them together. Beautiful, 15. How did it go? Did you at least get one right? Because that's all we can ask for. Okay, let's write a big old skip on this one. Not doing it, you guys don't have graph paper. It's not worth it when we're not together. So skip, flip your page. We are now moving on to altitudes. An altitude is a segment joining a vertex, so again, a corner of our triangle, to the opposite side so that it's perpendicular to that side. So again, keyword there is perpendicular, and we know that means to create a right angle. So a big tell is to make that it makes that box there. Okay. Altitudes can be inside a triangle, outside, or an actual side of our triangle. So I think on your notes, these aren't drawn in, so I'd like you to draw them. So traditionally, or like what we typically think of, your altitude is normally inside a triangle like this one. So it's coming down from our vertex, and it's creating a right angle. That's when you have like an acute triangle. If you have an obtuse triangle, one of your altitudes will fall out on the outside. So that's why it's like on the outside. It's not a part of my triangle, but it actually comes on the outside like so. And that's why these lines are dotted, is because they're not actually a part of that triangle. They're just showing that this is where the segment would fall. And it creates that right angle. So that's if you have like an obtuse triangle. And lastly, if you have a right triangle, your altitude actually ends up being a side, right? Because it creates that right angle by just the two sides of your triangle. And just like the other segments, we have three altitudes in a triangle. And these three altitudes intersect at a point called the orthocenter. It says use the diagram that left to answer the following questions. So it says list the altitudes. So we're looking for what, you guys? Those little boxes because they're perpendicular. So one would be what? C, D. Another would be A, E. And our last one would be BF. Name the orthocenter. That would be point P. And besides that, we don't really have a lot of other properties that would help us solve for missing sides or angles. So that's basically it for altitude. So it's kind of nice. Just know that it goes from a vertex and is perpendicular to the side opposite it. Now this is just a good review because we have a lot of new vocab and a lot of weird words that we haven't really used a lot up until this point. So I think it'd be a great time for you to, again, pause the video, fill in these blanks before I do them with you shortly. So take a second, hit pause, try these out, because the better and more familiar you are with these words, the lot easier the problems and just the understanding goes. Okay. I'm going to now do these with you. So here you should have put the three perpendicular bisectors of the sides of a triangle intersect at the circumcenter. The three blank blank of the angles of a triangle intersect at the incenter. Well, we know that those are the angle bisectors. The three blank of a triangle intersect at the centroid. Well, those would be our medians. The way I remember that is medians reminds me of meteors, and centroid sounds like a spacey term. So like medians and centroids just make me think of space. I don't know. That's how my brain works, but that's how I remember it. The three blank of a triangle intersect at the orthocenter. We know, we just learned that that is the altitudes. A blank is equidistant from the vertices of a triangle. That would be circumcenter. It is equal distance from the vertices of a triangle. And then our last one here, folks, a blank is equidistant from the sides of a triangle, and that is the incenter. Okay, kiddos, thanks for watching as always, and have a super rest of your day. And I can't wait to see you live in our Zoom, Meet, whatever you want to call it. Have a good one.